All right, guys, we are back. Okay, we're back. We're gonna hit it again. Operation Jackpot. Mind you, we're doing this one video a week. I really don't want to spend too much time on this. Now, I could imagine that watching hour-long videos of my thought process could be boring and tedious and whatnot. But nonetheless, I'm just recording the journey. See where this takes us. We have our goal set. So let's go ahead. Let's get to it. Now, the first question we asked previously was, is there such thing as random numbers, random events? That was our fundamental question. Okay, that really was our fundamental question. So we'll go ahead and me, I like to do my notes. Some people call it weird, but it makes sense to me. Nonetheless, with today, okay, and we actually got some really good research with today. Uh, can you guys tell that I'm trying to get into shorts? How to go ahead and make shorts on YouTube? ChatGPT, teach me. But nonetheless, we're going to go ahead. We're going to use AI. We're using GPT specifically for no particular reason. That's just something you just kind of get used to what you use. So ChatGPT's been there. So I'm sticking with ChatGPT, though I do have that DeepSeek video. I do use Gemini. Sometimes when I'm more than likely, I'm probably going to go ahead and ask the same question to all of them. But doing that for every particular question at one time, that's not something I really want to do. I just want if yeah, that's not something I really want to do. When the time comes, we're going to go ahead and use various AIs to ask them the same question when the time comes. But nonetheless, today is what, guys? Today is 2/6/25. We are in February in 2025. Man, this is crazy. Okay. And what I want to focus on, guys, is remember what we learned. We learned that there's a 1 in 300 million chance. Okay, I just say 300 million chance. So I don't have to read this number again. 292,201,338 odds chances of you winning the lottery. But we recently learned that there was actually people who went ahead and, believe it or not, won the lottery multiple times. So I'm just kind of like, dude, what was their strategy? If that's the chances of you win, most of us are gonna die never winning the lottery. You know, um, most of us. I can honestly say that. But these people, not only did they win the lottery, they won it multiple times. You know, I wish they would have documented the journey, be like, "Hey, how much money did you actually spend? Like, how much money did you actually have to spend before you won the lottery?" So on and so forth. I know they made a movie about Stefan Mandel. That's that guy from Breaking Bad that basically played him. I'm like 90% sure that was him. Um, that guy was a genius. Okay, that guy was literally going ahead and looking at the payment, and he's saying, "Hey, if it costs $5 to go ahead and cover all the numbers, and I'm guaranteed to win $8, I would pay the $5, cover all the numbers, and I'm guaranteed to at least have a net profit of 3." Okay, that was his strategy. They're saying that there isn't such a strategy, but I do want to add an element of that strategy. We're literally on our way to make the recipe. But before we can make the recipe, I think we have to study the ingredients. At least that's going to be my angle. Okay, Richard Lusting. Okay, his method was pick your own numbers. Don't use quick picks. Okay, so he's saying pick our own numbers. So I think what would be fun right now would be to actually go ahead and we're gonna have. This is what I'm thinking. We're gonna have one, maybe two, three, four, five. We're gonna go ahead and have a total of 6 strategies. Okay, so here's the idea. The idea, okay, the idea is to go ahead and have. We're gonna play once a week. Okay, so we're gonna go ahead and my spelling's horrible. Just get used to it. The idea is play once a week. Okay, so we know that it costs $2 to play. Okay, so it costs $2 to play. So $2 to play a line, basically $2 a line, and we're gonna have a total of 6 lines. So what each line stands for? So each line is basically going to be a strategy. Each line is a strategy. Strategy. Okay, so each line is a strategy, and we're gonna go ahead. We're gonna play the Wednesday. I think Wednesday is a great day to upload the videos, wait for the Powerball and whatnot. So we're gonna go ahead and play the Wednesday lottery. All right, Wednesday, and this is the Powerball. Okay, I know there's a bunch of lotteries. We're not gonna play all of them. We're just gonna focus on one particular one. So we're gonna do Wednesday lottery Powerball, and we are based in California. California. Okay, so that's the idea. So the idea is play once a week. It's $2 a line, a total of 6 lines. So that comes out to $12. Man, that's a lot of money. I'm not gonna lie, $12. And we're gonna do this for, I think the goal is 3 months. I kind of want to do just 3 months in total. We'll see how it goes. We don't know. But that's our goal. Okay, and we want to go ahead and make sure that we measure all of our movements. We're probably going to get an Excel sheet. Things that I was thinking of, things to review. I was actually thinking this would be a great opportunity to use Python. Python Panda for data analytics. I was watching some of those videos and it seems interesting. But nonetheless, I mean, why the heck are we going to use a tool if we don't know what our strategy is? Okay. Our goal is to get a total of 6 strategies and we can label these. So we're going to go ahead. Let me make this bigger. So we're not using ChatGPT yet. So we're gonna have a total of 6 strategies. So let's go ahead. Number one, dude, this is gonna be simple. This is gonna be baseline. This is baseline quick pick. I know what you're saying. Hey man, uh, what is it? First guy, Richard Lusting, he says, don't use quick picks. And you're using quick picks. Listen, I'm kind of treating this this is like a pseudo scientific experiment. Okay. I want to compare our strategy to what would be that of a quick pick. And I also want to compare Richard's strategy to what would be Mohammed's strategy, and Mohammed's strategy compared to what would be Joseph's strategy, so on and so forth. Okay. Mind you, there's a lot of variables. I can mess this up really quick, but that's one of the reasons why I'm actually recording. You know, so number one, so this is going to be our strategies, right? And number one is we call that baseline quick pick, and I think that's something that most people do. You know, they're like, just give me a quick pick. Some people do, hey, I'm just going to play my birthday, or hey, how are the stars aligned, or hey, what's the date today, or hey, we'll take this, subtract 2, add 1, multiply by 3, divide by 5. So I mean, the possibilities, guys, are endless. Okay, not necessarily. They're 1 in 300 million. Okay, so the possibilities are not technically endless. They're 1 in 300 million. So, but nonetheless, we have to have some type of strategy. For us, we're gonna have a total of 6. So the first one is baseline quick pick. Now, let's go to the Richard Lusting. Okay, so we're gonna go ahead and we have the um, Richard Lustig. Okay, so let's just go ahead and look at what would be his strategy. So we can do more research, but just based on this, actually, let's do that. We got some time. Let's do some more research. Let's verify our notes and make sure, okay, that what we have is accurate. You know, so just hey, you know what, this is what we had last time, but let's just verify. So Richard Lusting, strategy to win the lottery, okay, was question mark. All right, let's figure it out. Let's see what it was. Should match with what we have here, but I actually want to go ahead and start picking some numbers today. That's what I want to do, at least with his strategy, right? Because his strategy was pretty simple: pick your own numbers, don't use quick picks, stick with the same set of numbers consistently, play in bulk, except for bulk. Okay, so on this, we're actually not going to go ahead and play in bulk with his particular strategy. I know you're saying, hey, you have 6 lines, but each line is attached to a different strategy, so to speak. So throughout the 3 months, we want to use his numbers, right? So we're going to use these numbers consistently all the time. That's the goal. That's his strategy. So let's go ahead and say, so Richard Lusting, who claimed to have won the lottery multiple times, developed a strategy that he believed increased the chances of winning. While the lottery is ultimately a game of chance, there are key points from his method. Pick your own numbers, stick to the same numbers, use a balanced set of numbers. Don't rely on birthdays or special dates as they limit your number choice 1 through 31. Instead, mix high and low numbers. Play consistently, buy more tickets, join a lottery pool, manage your money wisely. Okay. So we're this strategy in it of itself is, dare I say, broken, because I mean, he gave us the rules and now we're literally breaking the rules, so we'll make a note. Okay, so he had, let's go ahead because this is today. So, and this is, we'll make this here. So this is going to be more notes about strategy. Okay, strategy. So, and this is going to be Richard Lustig. Hopefully, I pronounce his name right. Nonetheless, so pick your own numbers. Pick your own numbers. That's something we can do. So check, we can do. Okay. The next thing was stick to the same numbers. So stick to the same numbers. Check. That's something we can do. We can do that. That's not a problem. Number 3 was use a balanced set of numbers. Use a balanced set of numbers. Check. We can do that. We can do that. We can do that. Okay. And number 4, play consistently. Well, we can kind of do that. Okay. Play consistently. Consistently. Okay. We can kind of do that. Not a full check, but kind of. Kind of. Once a week. Okay. Number 5. This is where things get hairy. Number 5 was buy more tickets. Okay, so buy more lines, buy more opportunities. This is buy more tickets. So we have a set budget of 6 lines with only his strategy once. Okay. So basically, this is not a full check. So that's not even a check. I mean, depends on how you look at it. But I'm gonna say not a full check, obviously. Not a full check because we're only using his strategy once, right? We're gonna go ahead and compare these strategies. What was the next one? It was join a lottery pool. 6. Join a lottery pool. Okay. Not So that's a full-blown no check. No check. Not going to happen. All right. So we're not doing a lottery pool, guys. Please be aware of that. And don't ask. Manage your money wisely. Okay, I think we can do that. I mean, we're setting a budget. We're setting a time limit. Not everyone has $12 to blow nowadays. $12 is kind of a lot, man. I'm gonna be honest with you. That's a couple Red Bulls and a coffee at Starbucks. Manage your money wisely. Okay, I would say check. Okay, that's a good check because we're gonna go ahead and we have a budget. Check. We have a budget. Hopefully by the end of the 5th video or whatever, I don't say, hey guys, the only way we can really win is by increasing double. No. It just goes back to rule number 3, right? We're doing this shits and giggles, running an experiment. We'll see how it goes, man. We'll see how it goes. Okay. So more notes about strategy. Okay. Things to review. Python, using Python/Panda. That would be fun, Nonetheless, so strategies. So this would be strategies. Oh gosh, that's not how you spell it. Strategies, something like that. Strategies. This is our strategies. Let's go back. Strategies. Yes. Okay. Dyslexia takes over sometimes. Strategies. Okay, this is baseline. So strategy number one, baseline quick pick. Check. So this is number two. This is the Richard Lustig method. Method. Okay, so let's go ahead and pick some numbers now. Technically, I'm going to be honest with you. I haven't. I mean, I've seen it before. You know, when you just go to Cal Lottery and you see the numbers, but I have no idea. I promise you this. As the making of this video right now, I have no idea what was the last numbers, what was the common numbers, the cold numbers, the hot numbers. I have no idea. All I know is that you have a matrix between 1 to 69. You have a Powerball number 1 through 27, or is it 26? Yeah, 1 through 26. Okay. And this is his strategy. So we can literally pick numbers for today. And I got to be careful because I'm going to keep these numbers from now until the end of the experiment, right? Because that was one of his strategies. Stick to the same numbers, okay? And we're going to pick our own numbers, use a balanced set of numbers, play consistently. I think there was more. Let's see what else we have. Louis' strategy is more about responsible playing and increasing odds slightly, but it does not guarantee a win. The lottery is still random, and no strategy can change that fundamental fact, which was one of the first questions that we asked. And there was actually some discrepancy, right? Because if there's a machine, if there's a computer that's going ahead and picking out the lottery numbers, right? And this is a bit of a side note tangent, but it's important because we need to know what game we're playing. But nonetheless, if there is a computer that's picking these balls to go ahead and land randomly, we just learned that, hey, that's technically a definition of pseudo random, unless somehow, one way or another, you guys developed a machine that literally can have a quantum effect, which maybe, I mean, you guys give out lottery type money. Maybe you guys built a machine that can have a quantum effect. But nonetheless, the tangent, right? Tangent. Going back to the strategy. Let's go back to it. Pick your own numbers. We can do that. I know they had something. I know he had something more. He said play in bulk, use balanced numbers, mixing high, low, odd, and even. Okay, mixing high, low, odd, and even. Uh, I'm just gonna ask ChatGPT. Did he mention anything else, or how exactly he picked his numbers? Okay, let's do that. Let's go ahead. Yes. He detailed his approach to picking lottery numbers in his book, Learn How to Increase Your Chances of. Oh, actually, so he wrote a book. I bet, dude, I'm pretty sure just the way the world works, and the older I get, the more I realize he probably made more money on Learn How to Increase Your Chances of Winning the Lottery than he actually did from winning the lottery. That's a wild, wild, wild claim, allegedly, but it's, I don't know if it's true. I don't know. I don't know the numbers, but just sometimes how the way the world works. While he never claimed to have a foolproof system, he did emphasize consistency, strategy, and smart number selection. uh Avoid okay, so how Richard Lustig picked his numbers. So avoid consecutive numbers. Let's go and let's talk about that. Okay. Mix odd and even numbers. He believed that balanced selection of odd and even numbers had a better chance of hitting. Spread numbers across the range. Instead of clustering numbers in a small range like birthdays, he recommended spreading them across the full number pool. Keep playing the same numbers, track past winning numbers. Hey, that's what we're going to do. Okay, so let's just get to that. So within those three variables, okay, so remember that we have 1 through 69, 1 through 69 for the first five balls, and we have 1 through 27 for the Powerball. Okay, now we're gonna go even, odd. We're gonna go even, odd, and we're gonna go high. Let me go low, high. Just looks better, I think. I don't know, man. It's picking random numbers. Even, odd, low, high. So let's go for the first number. So our first number We want it to be, I don't know, what would make sense? It should be even, low, odd, high, even. Here's where it gets tricky, guys. If we go even, low, odd, high, even, low, odd, high, even, low, odd, high, we're not going to have a good balance of numbers. Okay, we're not. We're just it's gonna. I don't think we are. It doesn't seem right just off the top of my head. If we go even, low, and let's just write it out this way. Let's go even, low, odd, low, even, high. No, I mean we already broke his rule. See, this is a tricky one, and we're just supposed to pick. We're just supposed to pick 6 random numbers. Oh man, yeah. I'm stalling because I literally don't know what to do right now. Use balanced numbers, mixing high, low, odd, and even. Mixing. Okay, so we want to mix it. What would be the best way to mix it? Even, low, odd, high. And then how would we mix that? We can just go even, high, odd, low. And then we can go even, low, odd, high, even, high, odd, low. Okay. Even, low, odd, high. And then the next one, what would be the next one? Even, low, odd, high, even, high, odd, low. I mean, technically it would be, we can go even, mid, somewhere in the middle, and then we can go odd, mid. I mean, that looks pretty balanced, even, low, odd, high, even, high, odd, low, even, mid, odd, mid. Okay, so we have a total of 3 evens. We have a total of 3 odds. We have a total of low. Okay, and this is honestly where we can get into the number distribution. Okay, with Joseph's strategy, but that's a different strategy. And ideally, we could mix these. I mean, there's a lot of things going on in my mind, but I like this right now. Just, hey, man, even, low, odd, high, even, high, odd, low, even, mid, odd, mid. And we can even mix it where it could be even, low, odd, mid. But I think, yeah. Do you see where I'm coming from with this? Like, there's so many different ways to cut this. You can go, yeah. There's so many different ways, but I think for our strategy and just for the purpose of this, I think this is good. Even, low, odd, high, even, high, odd, low, even, mid, odd, mid. And we could have even flipped it, right? We could have gone, wow. I mean, you could have gone odd, mid. I mean, just flipped it on its head. You could have gone the opposite. You know what I mean? So it would have been, instead of starting with, I mean, I think there's 36 potential probabilities. So, because here's my variables. No, actually, and this is where I need help on math. So if one probability, because you have technically even or odd, and then you have even or odd is then mixed with high, low, or mid. So the first one would be even or odd, and then the second. So the first term, so to speak, is even or odd, and then the second term is low, high, low, mid, or high. Man, I thought this is going to be tougher than I thought. Nonetheless, let me think about it. Give me a second. You know what honestly would be probably better if we go even, odd, even, odd, even, odd, and low, mid, high, low, mid, high. You know what I mean? So if it was even, so just copying this. I mean, there's just so many different strategies. I could see why there's 1 in 300 million, and we still even haven't picked the numbers. So it could be even, low, odd, mid, odd, mid. You know what? I think we're overthinking this, but you see where I'm coming from, because this is exactly what we can go ahead and do. And the cool thing is you can flip it. But I do want to know how many potential possibilities are there. So if I have two variables, I don't even know what to call this. If I have two variables and that variable has two options, and one variable has two options, and the second variable has three options. Because I don't know, because I technically did make up the mid, because they're saying mixing high, low, odd, and even. So there wasn't even a mid, but I mean it's the general idea of using balanced numbers. Okay. um and mind you, this is before actually looking into the mathematical analytical analysis strategies. This is just kind of like, hey, this is random luck of the draw. But nonetheless, if I had two variables and one variable has two options and the second variable has three options, how would I calculate the odds of potential outcomes, so to speak? For example, first variable is odd or even, and third variable is low, mid, high, and I have to pick a total of 6. Does that make sense? Does that make sense? Let's see. I don't know. Let's see. Let's see if ChatGPT knows what I'm asking. I don't even think I know what I'm asking. Yes, I see what you're asking. You have two variables. First variable, odd or even, two options, and then second variable, range, three options. So odd and even, so times 6, you have 6 possible choices. Really? I have 6 possible choices? No, you don't. A total, find the total combination for 6 picks. You have, wow, so it looks like we have 46,656 possible outcomes if I ask the question right. And I'm going to be honest with you guys, I'm not going through that. I'm going to stick with this right here. All right. So, this is going to be our numbers. Okay. Let's just get rid of all this. This is our numbers. Our numbers. Numbers are. So first we need a even low number. Let's go with. I'm going with 4. Yeah, I'm going with 4. Next, we're going to need an odd high number. Mind you, that it basically goes ahead and starts with. It ends with 69. Uh, why not? We'll pick 69. All right, we'll play 69. Next is an even high number. So we need an even high number. Let's go with, for some reason. Okay, so we're back to picking numbers, guys. We're back to picking numbers. Um, my video editor cuts off right at the 30-minute mark, and I know these videos can be tedious and long, but nonetheless, I still want to record the process. So I have 4, I have 69, I have 22. The next thing I need is an odd low number. For some reason, I'm thinking 9. Mind you, this is completely random, so let's make a note of this. Let's see, when these numbers were picked, it was completely random. Completely random. And now that we have a different definition, okay, we're just gonna put that in quotes. Completely random. Okay, completely random, when these numbers were picked, it was completely random, trying to satisfy the above criteria, which was also at the time what we thought would be a balanced approach. Okay. Yeah, I mean, we're pretty much following the strategy. Pick your own numbers. That's what we're doing. We'll stick to the same numbers. So we're going to consistently play these numbers throughout the period of time. Use a balanced set of numbers. We can do that. Play consistently once a week. We already have our game plan. Buy more tickets. We already have our budget set. Join a lottery pool. We're not going to do that. Manage your money wisely. We had the budget. Okay, so I mean, so far so good. We're picking these numbers here. Numbers are 4, 69, 22, 9. The next thing we need to go ahead and pick is a even, looks like even mid number. Let's go even mid. I'm going to go 36. Yeah, that looks good because it's even. It's in the middle. I mean, if you have 69, that 69, so 70 options, divide that by 2, you get somewhere around 35. 36 is right in the middle. Oh, that's perfect. And then odd mid. Okay. Mind you, the mid now is 27. So if we just take 27, maybe 28 divided by 2, we get 14. We need it to be odd. So let's get 13. All right, guys. So these numbers are set. So this is what we're going to play for our first strategy. It took us a while to come up with these numbers. As you guys can tell, I think it took us like 20 minutes because we were just trying to figure out the strategy and whatnot. Let's go on to the next strategy. All right. So the next strategy was... So this was the first guy. Second guy was Stefan Mandel. Okay, the math genius. I don't think we can play this strategy. Okay, and the reason why I say we can't play this strategy is because remember his idea. This might work better for different types of lotteries, but his idea was, hey, if the payout is $1 billion, we need to get enough money, enough people, enough resources to basically go ahead and get all 300 million possibilities, and the cost of the 300 million is going to offset the cost of the 1 billion that we would win. After taxes, you probably get 50% of that, maybe even less, but it's going to offset, so you're guaranteed to win. But we don't have that bankroll, so to speak. So while this guy was a genius, okay, it is not doable. Okay, so let's go to number 3, and we'll make a note on it here. While good, okay, while good, it's just not feasible. It's just not feasible with the Powerball. For our situation. Okay, let's go to the next one. Okay, and this is where things get interesting. Okay, this is where we go ahead and we start focusing on goal number 2, which is data analysis. And this is where I think that we can definitely learn a thing or two. So, number 3. So we have our number set for number 2. I'm going to take this. I'm going to copy and paste this. Okay. And we're going to put this here. So that's literally going to be our numbers that we're playing. Now, strategy number 3, Mohammed Salam Ben Salem. Okay. I think that's how you pronounce it. So I'm going to go ahead and just take all this. We're going to copy this. And we're going to make this number 3. And we need to figure out what the heck was he actually doing? Okay. Mohammed Salam, number pattern analysis. What exactly was he doing? I mean, I don't even know. Like, number pattern analysis. I mean, like what exactly is the definition of number pattern analysis? Let's see. Playing in full picture. That's not what I asked. Come on, ChatGPT. Why are you giving me a hard time? I just asked a question. Is this a new feature or something? Just okay. There we go. Let's see. It seems like you may be referring, but there are no well references to him relating. What? You literally. Okay, right here. Red flag. Red flag. It seems like you may be referring to Muhammad Salam Ibn Saul, but there are no well known references to him related to number pattern analysis or lottery strategies. Can you clarify what you're looking for? Dude, remember when they said, hey, AI is going to take over the world? Dude, you guys literally saw me, okay, about a week ago, and I asked the question, and they literally said the opposite of what they're saying right now. Okay, so if you're a hiring manager, if you're one of those people who think, oh, AI, it's so smart, oh, AI is going to take over the world, look, okay, perfect case in point. Okay, now we're going to put ChatGPT on check and say, hey, man, you told me last time that Mohammed Salam Ben Salam won the lottery multiple times with a number pattern strategy. The fuck? Right? That's what you told me last time. Now you're telling me something different. Come on, man. Get it together, ChatGPT. Get it together. I might actually make a video of this too. Dude, that is so weird. Okay. Why are you giving this? So, hey man, you told me last time that Mohammed Salam Ibn Saul won the lottery multiple times with a number pattern strategy. I don't have any, and then ChatGPT comes back with, I don't have any record of Mohammed Salam Islam being a well-known lottery winner or using a number pattern strategy to win multiple times. You might be thinking of Richard Lusting, which we literally just freaking talked about, who claimed to have won the lottery multiple times using a strategy based on consistency and number selection. If you're looking for number pattern analysis related to the lottery, there are many different approaches people use, such as come on, let's go. Tracking past winning numbers, balancing odd and even numbers, using frequency analysis to pick hot numbers, avoiding common number patterns like sequential numbers. Okay. If you can clarify what you're looking for, I'll be happy to help. Okay. Dude, that is so strange, guys. Like, you guys, I might want to make a video on this. But nonetheless, we want ChatGPT on our side. So let's try not to go ahead and piss it off, so to speak. So, nonetheless, let's go ahead and let's just study the idea of number pattern strategy. Okay, so in short, what exactly is the theory behind pattern number strategy? So we actually get to our first, I guess, math question, so to speak. And let's see. I want to know, what is the strategy? Who came up with it? Who derived it? Who built upon it? Since when did this become popular? So on and so forth. Okay. So, we already see a red flag with what ChatGPT is telling us already. you know, uh, which kind of raises some eyebrows. It's just kind of like, come on, man, you're just gonna completely ignore what you said literally a week ago. But the theory behind number pattern strategies in games like the lottery is based on the idea that certain patterns, number. No, I mean, just give it to me without even the idea. Okay. But nonetheless, no, 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 no. Like, I don't know. I don't want the lottery definition of. Oh, there it goes again. Definition of mm, pattern number. Pattern number. I don't want the lottery definition of pattern number sequence, or what do they? What did we call it? Analysis? Analysis. Analysis. I want the actual math definition, the theory in general. Okay, so that way we can build upon it. Because I want to, like, I honestly, like, I get the idea, like, oh, there's some type of pattern, but like, oh, and I guess they did kind of mention it here, but okay, here we go. So, got it. Number pattern analysis in mathematics refers to the study of sequences, structures, and relationships in numbers to identify rules, trends, or predictable behaviors. This falls under discrete mathematics, combinatorics, and number theory. Okay, so believe it or not, I actually took a discrete mathematics class. I didn't get the A, but I got a B. So we'll see how and where that takes us. Number pattern analysis, but I don't like we didn't. But discrete math is very complex. There was literally like 14 chapters in the book, and the way we studied it and learned it, we focused on the first 7. So I mean, we might have skipped that chapter or idea completely. We did dabble a little bit in like com combinatorics, so in the sense of like, hey, what's the possibility if so on and so forth, like say you have a parlay, okay, and you pick two different teams, like you pick 2 to the 2, so there's four potential outcomes, so to speak, something along those lines. I told you, man, I got the B, okay. But nonetheless, let's see here. Definitions, we definitely dealt with definitions, but this right here, arithmetic and geometric sequences. Okay, that we touched upon. I know what that means. So this is basically the definition. Okay. So that's good. So that's something at least I know. Let's go further. Geometric sequence. Okay, that's its definition. So these are literally, when it comes to discrete math, guys, at least from what I know and I remember, we're literally dealing with what the definitions would be. Okay, so let's start taking some notes right now because this is actually pretty important. Okay, so of this is the idea of pattern analysis. So number pattern. Number pattern. Okay. So like this is literally like what would be math, so to speak. Like that is literally the definition of an arithmetic sequence, that equation that you see there. That much I know. So there's an arithmetic, arithmetic, and geometric, geometric, metric sequences. Okay, and let's put the definition. Okay, so an equals a1 plus n minus 1 d. Okay, now let's go to and basically the way this works is just looking at this from what I remember, it's just kind of like a sub n equals a1 plus n minus 1 d. Dang, I might have to have ChatGPT explain that equation, but I guess the best way to use that equation would be to have some type of problem. But the way I like to look at it is like, for example, If you have 2, then you have 4, then you have 6, then you have 8, then you have 10, then you have 12. Okay, you're going to go ahead and take the difference between this. I mean, depends on how you categorize it. I mean, we can use this as A1. Okay, so in this case, and this is simple, like, this is like basic fourth grade. Oh yeah, that makes sense. 2, 4, 6, 8, 10. What are you doing? Oh, you're consistently adding 2. Oh yeah, yeah. Look, pattern recognition. Haha, arithmetic. So on and so forth. But nonetheless, this is a super basic example. So in this situation, if you're just like, hey, if you have 2, 4, 6. Right, if you have 2, 4, 6, and assume you don't know the rest, you're just like, hey, what's going to be the next one? So you would just go 1, 2, 3, right? You're adding 2, so you're like, what's the fourth term, or what's the fourth term? And this is, I don't know, for some of us it might be like, oh, I never knew this. For some of us it's gonna be like, dude, that math is embarrassing. Of course we knew this. You had trouble with the equation, so on and so forth. Doesn't matter. 2, 4, 6. Okay, so you're just like, hey, what's the fourth term? So you're gonna go a sub 4, you're gonna go a1. So a1 is gonna basically be, a1's gonna be 2, right? I really got to get some type of notepad. So a1's gonna be 2. So you have, let me get back here. Oops, not that far back. You're going to go ahead and have an equals 2 plus, okay, and you're going to go ahead and have n minus 1, since we're trying to solve the fourth term. So you're going to have 4, okay, minus 1, which is what? It's going to be 3. And then you're going to have the difference, which is plus 2. Okay. So you go ahead and multiply 2. Oops, 2. Okay. Then 2 times 6, excuse me, 3 times 2 is what? It's 6. 6 plus 2 is what? Is 8. So the fourth term would be 8. Okay, so yeah, that makes sense. Cool, cool, cool. All right. I know I kind of erased some things, but at least it gives us an idea. And it was a little bit of a brain check for me, just to make sure, hey, can you solve this super, super simple thing? Now we have geometric. Okay, so we have the geometric sequence, geometric. And now this is more so with regards to, this would be like, oh, we have exponential growth. I think that's what it's regards to. And this is an equals a1 times r to the n minus 1. Okay. I don't have an idea off the top of my head for this one. But actually ChatGPT does. Okay, example 3, 6, 9, 12, 24, 48. The common ratio is 2. So it would be 3 to the 2. Would it be common ratio? Oh, I see what it's doing. Okay, so it's basically 3 to the 1 is 3. 3 to the 2. No, that wouldn't even work either. Common ratio is 2. Oh, so it's multiplying by 2. Okay, so instead of adding with geometric, you're either going to divide by 2. So i.e. divide by 2 or i.e. divide by 2 or multiply by 2. Multiply by 2. Okay, so one of them is going to be, and this was arithmetic, so you're adding subtraction and addition. Okay, and then now you have geometric, which would be division and multiplication. I mean, you can have logs too, and you can have exponential or an exponent and whatnot. Let me see here: modular arithmetic and residue patterns. This is where things start to get voodoo. Okay, if I'm thinking of it correctly, because it says use to find cycles of repeating patterns in numbers. Example, looking at numbers mod 3 will get a repeating pattern. We didn't do too much of that, but mod 3. So it's counting in threes. So since this goes 1, 2, 0, 1, 2, 0, 1, 2, 0. But nonetheless, let's write it down. And we might need ChatGPT to explain this a little bit more. Okay, modular arithmetic and residue. Those are like those YouTube videos where people put like, "Hey, why is it that every number adds up to 7, or every sequence of number adds up to?" Nikola Tesla was known for this. It was like, if you want to understand, I mean, he was quoted for a lot of things, but he goes, thinking, if you want to understand the secrets of the universe, think in terms of frequencies and vibrations. But the other thing he said was with regards to 369. Those were his numbers. 3, 6, and 9. And that could have been an arithmetic, that could have been a geometric, that could have been modular, or maybe going ahead and taking all three of those styles and actually seeing that there is a correlation between the 3, 6, and 9. And actually, we can ask ChatGPT that as well. I.e., I'm still having a hard time with modular, but i.e. mod 3. Mod 3, and this is 120120. All right, let's go. And combinational patterns. Okay, so that was basically mixing it. Oh, actually, no. Fibonacci. So you have combinational. So as you guys can see, this is pretty complicated. Holy crap. Chaos and randomness and number sequence. Dude, I think we might have bit too much. We bit more off than we can chew. Fractals and self-similarity numbers. Some sequences exhibit self-similar properties, such as the Cantor set. Triangle often analyzed using recurrence. What the heck is this? Chaos and randomness and number sequence. Logistic map and chaotic system. This is used in pseudo-random number generators and cryptography. Real-world applications of number patterns. Uh, Dude, can you imagine that basically could you imagine that the lottery numbers are just some type of cryptographic message that's attributed to some word that is based upon the actual day of the year, and what have you? Like, dude, like, I'd be laughing my ass off, because basically if you really think about it, right? Because cryptography is basically nothing other than math, and it's just really complicated, above my pay grade type of math that I'm trying to learn. But nonetheless, this is, I mean, at least we have some type of idea. Here's the thing, though. If we're being honest with ourselves, right? Because remember what we asked ChatGPT? We asked ChatGPT, hey, man, give me the mathematical thing. Right? I asked it specifically, no, I do not want the lottery definition of pattern number analysis. I want the actual math definition, the theory. So this is the theory with regards to mathematical definition of number pattern analysis. They basically gave us 5. Okay, you have the arithmetic, you have the geometric, you have the modular, you have the combinatorial patterns, and then you have the fractals and self similarity and number patterns, and then you have chaos and randomness in number sequence. I was already struggling with the first 2. 3 and 4, especially 4 and 5, are going to go ahead and be some type of head scratcher. Fibonacci makes sense, though. It makes sense in my brain. I don't know if I can describe it, but it's just basically it adds upon itself, so to speak. And you need at least 2 numbers to start with. So, but nonetheless, I think maybe modular. I'm gonna go ahead and make sure I put Fibonacci. Let's put the equation for Fibonacci as well. And look, there's even more. So in short, what exactly is the theory behind pattern number strategy? And actually, I didn't even read this. Frequency analysis, they have hot and cold numbers. They have odd and even. And we're going to actually take that as well. And we're going to work with what we got, and we're going to work with what we know. And we don't mind learning some new things. But dude, this is definitely becoming something more than I expected. So on this one, aka Fibonacci, and we're just gonna copy down the definition. Fibonacci sequence, and the definition was Fn equals Fn minus 1 plus Fn minus 2. And we're definitely going to be having to go ahead and do some Python. We're definitely going to have to go ahead and do some Python. Fun fact, algebra was actually, I believe the term algebra was created during the Persian dynasty, um, using letters as numbers and numbers as letters and vice versa. But nonetheless, chaos and randomness. There's also fractals, okay, and self similarity. I don't even know what that means. And then the fifth one was chaos and randomness. Chaos and randomness. Number sequence. So this is the mathematical approach, right? This is the actual mathematical approach, like with regards to just getting your definitions. And on this one, I mean, they had it. I wonder what this means. I wish they could explain this to me. Which let's go ahead and do. Logistic map. Okay, let's end with this. Okay, with logistic map. Okay, so that was xn plus 1 equals rxn 1 minus xn. And let's see. Hold on. We have a couple things, and let's get to it because they also had a few other definitions. Okay, not because remember this is the mathematical definitions, but they also had a couple things here. They had, and this was before I asked for it. They had key concepts of number pattern strategy. So let's go ahead and copy that. So, and we're gonna have to basically put this in code. Key concepts of number pattern strategy. Let's see. I don't know, man. Muhammad is complicated. Freaking Richard was simple, right? It was just kind of like, oh yeah, I'm not doing all this math stuff. Hot, cold numbers. Okay, that's one. That's pretty simple, right? You can just look at, hey, within the past month, what lottery number was happened to occur most often, and out of the last month, and of course you can take your time frame, last month, last 3 months, last 6 months. You can get as particular as you want, but the idea is like, hey, this number has shown up multiple times. It's the hot number right now, right? And vice versa with cold number. So that makes sense. This whole idea of odd and even and high and low balancing, it's it's interesting, but I don't know how they put that. But they at least they gave a definition, so that's actually something I like. And it looks like I kind of might have messed up because odd even, high low, balancing. Because remember on my strategy I put mid, which I don't know if it's something that it was good. My intention was to balance out the numbers, so I'm not too sure. But nonetheless, many lotteries rarely play all odd or all even numbers. Players try to pick a mix of odd and even numbers or balance low. So low equals, so now we actually have a definition, which I think our definition was pretty good. Low equals 1 to 25. High equals 26 to 50. Okay, so we can use, so moving along with this strategy, we know, hey, this is going to be our definition, right? Avoiding common patterns. Many players choose their birthdays. Dude, this is literally copying and telling us kind of what Richard. So notice there's a lot of correlations. Basically, everything I read so far has been Richard's strategy. Okay, and there's technically no there's math to it, but yeah, there's a level of math, a very elementary level of math. Wheeling system. A lottery wheeling system organizes numbers into multiple tickets to cover more combinations. That might be interesting while ensuring at least. But this is kind of like this is kind of what Stefan was doing, so to speak, I believe. Delta system sequential difference, a method where numbers are chosen based on differences between previous numbers rather than absolute values. Example, instead of picking 5, 12, 18, 25, you analyze the gaps 7, 6, 7, and use similar spacing. Okay, that makes sense. So if instead of picking 5, 12, 18, 25, you analyze the gaps 5, 6, 7. That's probably something we're going to do. Delta system. So the idea of delta system. And we could probably get a delta system equation. Um, delta system, i.e., if you have 5, 12, 18, 25, gaps are 7, 6, 7. Okay, let's see. Does it work? Lotteries are so random, so no strategy can change the odds. However, pattern strategies may help you optimize number selection, and that's exactly what we're trying to do. So that works. And you know what, guys? Let's go ahead and leave it there. No, I lied. We're going to a logistics map. I want to. Okay, Chat GPT, and this is going to be the last question, guys. Chat GPT, please explain. ChatGPT, please explain logistic map to me in simple terms. Okay, explain it to me in simple terms, please. Let's see what it says. All right, ChatGPT. So it gives us the formula. So here, I guess here's the formula. A number between 0 and 1 represents a population of or amount of something. A growth rate, a number between 0 and 4 that controls how fast things change. The next value based on the current. If there are too few, they multiply. If there are too many, they run out of food and die. The logistic model rather follow in a simple way. I don't know what I read. It behaves based on our growth. What is this like? Like values. I don't think that's what I was expecting. But nonetheless, that's the formula, and I do believe we have the formula. So xn equals xn equals number between 0 and 1 number between 0 and 1 i.e. population or amount of something okay. R equals growth rate, a number between 0 and 4 that controls how fast things change. Growth rate, how fast things change. And right now I'm literally just looking and typing because I don't know exactly how this would apply to our situation. Next level based on current value of xn. Next value based on current value of xn. And to be honest with you guys, let's leave it there because I know this is a lot. We said we were just going to spend an hour, and it seems right about right. So technically, we have our day 2. Okay, this is our idea. This is our game plan. We're going to have $2 a line with a total of 6 lines. I should probably make 5 to 6 lines because we are taking out Stefan's specific strategy. Okay, one of the guys that won the lottery multiple times, and it looks like it's going to be a total of $12 once a week, and we're going to try it for 3 months. I wonder what is that? That's going to be what, $36? No, that's $36 for 3 weeks. Oh shoot. What is that? 12 times 4, that's going to go ahead and be 48. Let's just round it up to 50. Dude, this is like a $150 project, bro. $150 project. $150 project. Overall, let's roundabout. I mean, subtract 2, 4, 6, basically $144. I think it's gonna be $144. Yeah, I think I could be wrong. Nonetheless, we'll take out our handy dandy. I don't have my calculator, do I? Let's go ahead. When in doubt, check your calculator. Calculator. Dun dun dun. Yes, it's 12, 4, 6. No, it's 12, 24, 36, 48. 48 times, I know I like to look 50. 50 times 3 is going to be 150. But that was 48. So you subtract the 6. So you're going to have 144. But I just want to double check. 12 times 3. Okay, that's basically. Oh no! It is 12 times 4, because you have. We're gonna play once a week for 4 weeks. 12 times 4. Okay, once a week, which is $12 for 4 weeks. That's 48 times for 3 months. That's 144. Yeah. So basically $150. All right. Well, guys, that's going to do it for us. And we'll see you guys on the next one.